Okay, so finally, I'm going to look at the 1.4, 1.5 part 2. Okay, it showed us, we did some calculator skills here, but also we were looking at some linear functions, some quadratic functions, and thinking about domain and range. So I actually already uploaded a video going through number 1 and number 5. So I'm just going to focus in on number 2, 3, 4, and 6 and on. So we'll start with number 2. First of all, I'm just going to annotate here. Okay, so first thing here is, does the table describe a function? And so remember that the definition of a function is each input has exactly one output. And so my inputs are -2, -1, 0, 1, and 2. And it looks like each one of those has exactly one output. So yes, it is a function. Oh man. Each input has exactly one output. What type of function is described by the table above? Well, this is going back to reminding you of some things that you've probably looked at before, but this is +1 change in x, +1 change in x, +1 change in x, +1 change in x. And this is -3 change in y, -3 change in y, -3, -3. So that means that our slope is -3 over 1, or -3. And that's a constant slope. And we know that functions with a constant rate of change are linear. So this is a linear function. If we can assume the pattern continues, so let's just assume that it keeps going and that this is a continuous connected function. So all the points in between, like 1.5 and pi and 2.33 and all those are part of the function. What would be the domain and range? Well, domain and range, interval notation to report your answer. Let's see here. I'm gonna have to stop for a second here. Sorry, I just had something pop up there. Not sure if you could see that or not. But anyways, coming back here. If the pattern continues, then using interval notation, we actually get that it is all real numbers. And so we would write that the domain is -infinity to infinity. We're going to assume that it keeps going, and that the range is -infinity to infinity. Okay, we use the parentheses because you can't include infinity. You can't tame infinity. It's infinity. It's an idea. It's not even a number. Okay, for number 3, for the graph at right, state the domain and range using set builder notation. So I'm going to make an assumption that this keeps going, which is maybe a dangerous assumption, but I'm going to make that assumption. And so I'm going to say for my x values that it goes all the way this direction and all the way this direction, because I think it's going to keep going up here and down here. And that for my y values, it's going to go all the way down and all the way up. So again, I think that my domain and range are all real numbers. But set builder notation, I would write x such that x is an element of the reals, or y such that y is an element of the real numbers. Okay, so this is a fancy notation. You can also just say all real numbers, or you can write all real numbers. That's fine. Okay, scrolling down. What type of functions are described in question 1 through 3? Well, they're all lines, we saw for that. So these are linear functions. What pattern do you notice for domain and range? Yeah, it is always all real numbers for both. Can you explain why this pattern for domain and range exists by looking at the equations? So when you have, say, y equals mx plus b, you can plug in any x value, right? Because multiply x by m or anything, that's fine, and add. There's no problems for plugging in any x values, and get out any x value. So it's maybe hard to describe. That's how I would say. There's really no problems here. So I can plug in any x value and get out any y value. Excuse me, because that's what you get out. Okay. Number 5. Use your calculator to investigate this, but I did that in the other video, so I'm going to move past that. Consider the function represented by the table below. The table includes the maximum y value of the function. Okay, maximum y value of the function looks like it might be 2. Okay, interesting. I wonder if that's supposed to say minimum, but whatever. And you may assume that this is a continuous function where the x values continue in either direction. We might have a contradiction here, but we'll see. What type of function is described by the table above? Okay, well, let's see. If I graph it, that's a good way to help me figure it out. So negative 2, 2 is right there. Negative 1 is right here. Oh, I see how this is working. 0, negative 2 is down here. Well, I guess this point is a little off, so I guess I'll put it here. 1, negative 1 is here. Oh yeah, we've got some issues here. And 2, 2 is back up here. So I think we've got a typo, unfortunately, because if this keeps going in either direction, it's not the maximum that we have here. It's the minimum. Yeah, so I think we've got a typo here. Whoopsies. It's my bad. And so this is a what we would say a quadratic function, since it looks like a parabola. Domain and range. Okay, so domain is, I think this is going to keep going in either direction. So we'd say negative infinity to infinity. And the range is from here up. So the lowest value looks like that's supposed to be negative 2. And the highest value is infinity. So we would write negative 2 to infinity. That's our domain and range there. But that should say minimum value there. So that's my fault. Okay, scrolling down to number 7 for the graph, state the domain and range. Okay, so domain, again, can go all, if I assume this keeps going, it can go all the way left and all the way right. So the domain we're going to write as x such that x is an element of the real numbers, just means x is a real number. And the range we are going to write as y such that, so what's the smallest value of y? Well, negative infinity down here, and the highest value is 8. So we don't actually need to say that negative infinity is less than y. What? Negative infinity is less than everything. So why would we write that negative infinity is less than y? We just don't need to say that. So we can simply just say y is less than or equal to 8. Okay, it's less than or equal to that value. That's our range. Okay, let's see here. Scrolling down, Nikola Jokic, maybe, is known for his hierarchy in three-pointers, mid-range floaters. He used them to end the Clippers season, take his team to the conference finals. A certain three-pointer, he was 28 feet from the rim. Draw this thing out, okay? Boom, 28 feet. Here's Nikola. He had the ball leave his hand at 8.2 feet, comes up, reaches a certain height, and comes out. Let's see, this right here would be 21 feet up here, reached a height of 21 feet. Before getting nothing but net and then hitting the ground. Okay. Good. Well, it looks like to me that the domain in interval notation, so let's call this 0. And let's call this, it's probably a little more than 28 feet because the basketball is 3 feet. Let's see, 28 feet from the rim. So the basketball hoop might be here. And so it might be a bit more than 28 feet. So I'm going to say, you know, maybe like 0 to 29 might be the domain. And the range I'm going to say is 0, which is the smallest value, up to 21, which is the highest value. Is there a difference between the domain and range in the context of the problem? And if we made an equation to model it? Oh yeah, if we made an equation to model it, this would come back down here, and this would keep going here. It's just that that doesn't really make sense if it's stopping on the floor. So let's see if we can clear all these drawings, but then we might say, yes, for the equation, it would be all real numbers for the domain and values less than or equal to 21 for the range. So in the practical world, we stop because it hits the ground and, you know, but in the real world, we'd have bigger domains and ranges. Okay, finally, what type of functions are described in 5 through 8? Well, these are all quadratic functions. Okay, with the shape of a parabola. Is there a pattern to the domains? If so, what is it? Yes, there certainly is. The domain is always all real numbers. You can plug anything into a quadratic function. Pattern to the ranges? Explain. Yes, it is either less than or equal to the max or greater than or equal to the min, right? So it kind of depends here on, well, what do we have? Because if we have a function that looks like this, then it would be, you know, let's say that this is k, then it would be y is less than or equal to k. But if we have a function like this, then it would be y is greater than or equal to k. So it kind of depends on whether your function is opening up or opening down. So I hope you find that helpful. That sort of takes care of this assignment. So yeah, upload that once you're feeling good about it, or stop by conference and check in with your teacher, which could be me, or in case you're in another class, could be Raina or Devin. And so that's it. And hope you have a good Wednesday or whatever day it is.